Welcome back to my whiteboard. I'm Muriel Medard, CEO, co-founder of Optimum. Every chain, including of course Ethereum, has a ceiling, and that ceiling is in great part delimited by how much data it can carry. In my 2.5 decades of research at MIT, I've been working on exactly this problem. How can you, in a decentralized system, speed up and improve the flow of traffic? So to do that, let's see what Ethereum does today. What it does is it propagates traffic using a decentralized mesh called GossipSub. And in this mesh, nodes are talking to each other in a decentralized, very loosely, locally coordinated way. That's great for decentralization. So what's the problem? The problem is that a node here might listen several times to the same data. Maybe it gets 2 copies of X1 and it gets a copy of X2, and it has to wait a long time before it gets a copy of X3. Maybe it needs X1, X2, and X3 to get ahead. So this becomes an issue. Now you might say, is it such a big deal that we get some repeats? Do we need to be 100% efficient? Well, the problem is the following. We're on the clock. Ethereum is on the clock. So anytime that you spend not processing useful data, but processing stale data, it's time that you're not spending doing something that's useful and actually making the chain go forward productively. You're on the clock. You've got 12 seconds to get the job done. And out of those 12 seconds, 4 of them are dedicated to the validators having to basically agree to what's right now at the top of the chain. In order to get that agreement in 4 seconds, you need to basically currently make a lot of some, inefficiencies that you would rather not do. And in particular, these inefficiencies, and this is where the decentralization comes in, can be particularly marked for people, i.e. for validators, that are far away from where the blocks are actually starting. So if you have a block builder over here, and you have proposers and validators that are close together, well, these proposers and validators are going to be able to be much more efficient because they know that they're going to get the blocks fairly quickly. If on the other hand, you're a validator out here very far away from where the action is starting, the chances are that you will see older information and that having these kinds of repeats are going to be more hurtful to you. So what's happening is that these inefficiencies are leading to a slow, sluggish network, which means that the delay is at a premium, and therefore there's a premium for being co-located. Now, co-location runs, of course, exactly counter to the idea of decentralization. If I'm a validator in Australia, I should have the same chance as a validator in Europe or North America. Why is that not the case? It's because this distance and this extra delay is exacerbated, is aggravated by having this repetition. Okay, so what do we do? What we do is, instead of sending these repetitions, we make optimum use of whatever bandwidth is available. So this node, for instance, say that it's a validator, instead of seeing X1, is going to see some equation, maybe 3X1 plus 2X2 plus X3. And here, instead of seeing X1, is going to see another equation, maybe X1 plus X2 plus 5X3. And maybe this other one will be another equation, say 11X1 plus 2X2 plus 13X3. These 3 equations will suffice to get the X1, X2, X3 data that is needed for this validator to get the job done. So now validators that are far away don't suffer as much as they do in the current system, where you basically get these inefficiencies that are compounding as the network grows. We don't get any compounding of inefficiencies. So there will be a little bit of extra delay just because, propagation of light and so on. But the bulk of the delay, which comes from the clogging up of systems, is not going to be there. So that's how, using our technique, which we call random linear network coding, or RLNC, we can massively improve the performance of validators that are far away and allow them to compete in the same way as validators that are co-located to where the blocks are being built and proposed.